Good morning, YouTube. Today we are continuing our series of SAT Khan Academy problems being solved live. And today we're going on to similarity and congruence. Without further ado, let's jump right into it. So I got the problem set up. We will go to the share screen right now. And as always, I'm seeing these problems for the first time with you. So we shall see how it goes. It's part of the fun. Let's throw this one up here. Congruence and similarity. Oops. Let me see here. There we go. Excuse me. This is early. I think it's before 5 still. Okay, here we go. Oops. And let's get this one loaded up here. We're almost done going through the entire Khan Academy suite of problems, at least the first time through. All right, see, given the angle measures and the figure at left, what is the value of R? And these are pretty fun. So these come down to a lot of angle rules with triangles and vertical angles and so on and so forth. The way that I like to do this is I just start applying whatever rules I can think of with respect to angles, and slowly this thing comes together. The first thing I love to do is apply vertical angles because they're super easy. All you do is you look at two angles that are formed by straight lines like this that are opposite each other, and they both equal each other. So right off the bat, we got 50 degrees in here. Well, and then now I got two angles within a triangle, and we know that all angles in a triangle, oops, my microphone's over here. All angles within a triangle add up to 180 degrees. So 50 plus 75 is 125. So that means that this right here is going to be 55 degrees. It has to be. All right, because all angles always add up to 180. Now that we know that this is 55, we can tell by these two guys, R and 55 are supplementary because they're on a straight line. That means in total, they add up to 180. A straight angle is 180 degrees. So if that total is 180, that means R plus 55 is 180. That means R is 125. There's another theorem that we could have used with exterior angles, but that's usually how I like to do it. I don't even like to think about that one. There we go. Excelentes. Let's move this one back up here too. Clear the board. Oops. 3, 2, 1. It's just now 5 a.m. here. And to begin, and Nikki Bella says hello from Instagram. Hey, how's it going? I hope these are helpful for you. By the way, if you want to see me actually solve these problems and watch the whiteboard, go to YouTube, search for my channel, Scalar Learning, and you'll be able to actually see the problems, not just hear me talk about them. Let's take a look at this one. So it says two figures are shown above. The left figure has two vertical lines and another line intersecting both, meaning they're also parallel. The right figure is similar to the left figure. What is the value of theta? Similar. Well, similar basically means those angles are going to be the same. We're trying to find theta. Just off the bat, I'm going to say that theta is going to be 45 because those are alternate exterior angles. So if they're similar, that means this is 45. I'm just going to make sure I'm not rushing that too much. Yeah, I mean, I'm pretty sure that's right. That's 45, and then that's got to be the same. This again would be 135, and we can say by alternate interior angles that this has to be 135, and then this has to add up to 180. So yeah, it's just 45 degrees. That one's pretty straightforward. Let's give it a shot. Let's enter it and see if we're right here. 45, it is correct. All right, let's go on to number 3. Seems to be not such a bad topic. Okay, so what am I doing? What I'm doing right now is I'm solving Khan Academy SAT problems live to help students prepare for the SAT. So I'm just responding to the Nikki Bella on Instagram. All right, here we go. Question 3. Given the figure at left, which of the following statements is true? Triangle DEF is isosceles. Okay, let's see. Let's take a look at all this stuff here. Well, by the way, DEF is not. Wait, maybe it is. Hold on. 8. Okay, so again, I'm going to follow the same strategy. I'm going to fill in everything that I can tell. Now, remember, I've told you first thing I like to do is vertical angles. We got a set of vertical angles right here. So that means this guy down here is 86. Now we can fill in this angle because triangles all add up to 180. So 86 plus 42 is 128. Okay, you can, I think this is a calculator section. You could have used your calculator. So that's 128. So what does this have to be? This has to be 52 over here. 52 degrees. It has to be. What about over here? We got 52. We got 86. These guys add up to 138. So what does this have to be down here? This has to be 42. Okay, I think I already know what they're getting at. So this has to be 42. No, triangle DEF is not isosceles because an isosceles triangle has not only two sets of equal sides, but it's got two sets of equal angles. So these guys, all the angles are different. These two triangles are scaling. Raise CA and EG. Hold on, CA and EG are parallel. This is true, but I'm going to come back to that. That is true, and that is probably our answer, but let me come back to it, and I'll show you why in a second. Segments CE and BF are perpendicular. CE and BF are perpendicular. This is not true, because in order for the two lines to be perpendicular, they need to form a 90-degree angle, not an 86-degree angle. So we can disprove that. Angles BDC, that's what perpendicular means. They meet at a right angle. BDC and EDF are supplementary. BDC and EDF. They are not supplementary. They are vertical angles. If they added up to 180, yes, but they add up to 172. 86 and 86 have to be, have to add up to 180. So we've chosen B by process of elimination regardless. But why is it true that they are parallel? It's because this angle is 42 and this angle is 42. These two angles are alternate interior angles. When alternate interior angles of two lines are equal, they are indeed parallel. So this is our transversal right here, EC, and basically we see that these two angles, opposite alternate interior angles, are equal. Has to be parallel. B's got to be the answer. All right, so let's go in here. They are parallel, and that is correct. We have done it. Okay, here we go. Let's go on to the next one. Question number 4. I see Spatus is saying geometry is her life, and that's awesome. I love geometry. All right, we got 2 problems left here. Let's go to this one. Question 4. The figure at left was made by first drawing line segment AB and then drawing JK, which is a segment of the perpendicular bisector of AB. Got it. So perpendicularly bisect. So this is also perpendicular bisector. This forms a 90-degree angle also. So I'm just going to put in these little guys here. Which of the following statements must be true? Okay, so again, let me just read everything. Perpendicular bisector. Okay, so I'm going to see if there's anything I can fill in here. I'm going to look around and see if anything makes sense. We got 6, we got 2. We got 2 there, or we got 2 equal sides there. No, this is definitely kite. These guys are bisected. Not sure. Okay, so let's take a look and see their options. AJB and AKB are isosceles. AJB and AKB are isosceles. I don't know if this is said yet that this is a kite. They definitely look isosceles. They definitely look isosceles. I don't know if we have enough information. Let me see. If it said it was an angle bisector, I could say for sure. I don't know if we know that exactly yet. That those two are congruent. I'm just trying to see if there's any more information that I can glean from this. Those two sides are equal, 490 degrees. Oh, wait a minute. We can, because I just realized. All right, this is how I'm doing it. So basically, we can show that these triangles are congruent, and therefore, I don't know if we can say they're isosceles, but we can say they're congruent. So this triangle is congruent to this guy by side angle side. Okay, this is kind of almost like geometry type proofs here. So we've got this side, these two angles, and then this side is shared by reflexive property. It's equal to itself. These two triangles are congruent. These two triangles are also congruent. Same principle. Side this side and this side that we already know are congruent. These two angles, and then this side. Put 3 dashes. It's unique. So we know that we know that this triangle is congruent to this triangle, and so we do know that that's kind of interesting. And if it's congruent, if these two triangles are congruent, that means that this side here, let's do 4 dashes, 3, 4. This side must be congruent to this side, and this side, let's do 5 dashes, must be congruent to this side. That's by congruent parts of congruent triangles are, or corresponding parts of congruent triangles are congruent. So actually, we do know that they're isosceles. But let's come back to that. Triangle AKB is isosceles. AJB is not. No, they're both isosceles. They are congruent. AJB and AKB are no. They're not congruent. I mean, congruent is another word for equal. AJK and AJK and AJB. No, that's crazy. AJB. All right, so we're gonna go with A. So they are indeed congruent. That was a little bit trickier because it didn't seem so apparent. We had to do a little work there, and it is correct. They have said it's correct, so we are good to go. By the way, let me know in the comments if you want more of these types of problems, or if these are the ones that are really tripping you up. I'm happy to do more. Once we complete the cycle of all the SAT math problems, I think that I'm going to go back and focus on other problem areas. I think I'm also potentially going to just run through them one more time on the level 2 problems to kind of go up in level after you go through everything once. Let's try this guy. In the figure at left, rhombus A. So they're telling us that they're rhombuses. A rhombus, if you don't know, is it's a four-sided figure that all the sides are equal. So like technically squares are rhombuses. So I'm just going to put markings. So they're saying both of these are rhombuses. I'm just going to put markings to indicate that all the sides are equal. 1, 2, 1, 2, 1, 2, and 1, 2. And it's interesting. They're using this marking for the angles. And I think what they're saying that the angles are equal, which is really weird. But like within the rhombus, because they don't look like they're all equal. And if they were all equal, they'd all be 90 degrees. It'd be a square. I'm just not totally sure what these markings are, because usually they indicate that they're all equal. So this is a little bizarre. But anyways, it doesn't matter. If they're similar, it means the corresponding angles have to be equal. So we can say, so what are they saying? They're saying that D equals F. D and F are not corresponding angles. Though they would be equal if they're rhombuses and they're sort of like opposite. They actually would be equal. So it could be A. Let's just come back to that. D and G. D and G, at least from the looks of it, definitely not equal, right? These are angles like this. I mean, according to the markings, they would be almost, unless I'm misinterpreting them, but they do not look equal. I'm going to cross that off. We're going to stay with D equals F as our strongest choice right now. D equals 90 minus G. Basically, this is saying that D and G are complementary, which is definitely not true, because they definitely equal way more than 90. G itself is bigger than 90. This is saying that D and F are supplementary. D and F, no, they're not supplementary, not necessarily, and they're definitely not in this case. They look to be way less than 180. So we're just going to go with A. I mean, this is what happens with similar figures. It's just odd because the markings are a little bit off. Like what they should have done is had two lines like this to show that they're different. So then the ones with two lines would be equal to each other. One line would be equal. So we're going to go with angle D equals angle F, which is A. We're going to choose that. And it is correct. So we have done it. Let's go back to live stream. And that is it for today. Thank you guys so much for joining. I hope that was helpful. We will continue again tomorrow morning. If you guys have any questions, please comment below, like below if you like this video and if you found it helpful. And feel free to email me at huzaifa@scalarlearning.com if you have any additional questions. Thank you guys so much for joining. Hope you have an awesome, awesome day. Take it easy.